Okay, good morning. Welcome to
FamilyMath755.
FamilyMath755. So today we're going to study a very interesting problem called the graph isomorphism problem. And the first thing I need to do is explain to you what I mean by a graph in this context. So a graph that we're going to talk about here is not a graph of a function like you might be learning about in school, but just a collection of points and lines that are connected.
Okay.
And so, all I really have are just lines and points. Yeah, I just pointed to the same thing. So lines connecting points.
Do they have to be? Does that have to form a complete shape? Like, could you have like a point and then a line and then a point and then a line?
Try what you mean?
It's like with this, a graph.
Good question, actually. I think no. I think lines can only connect points.
Okay. So like this would be a graph.
That would be a graph, and in fact, this would be a graph, too. So you can't have a straight line, but I think you can have a straight point.
Okay.
And you can have crazy things, like this, or even maybe something could be connected by two lines.
Okay.
And the lines don't have to be straight lines. So the problem here is figuring out when the graph isomorphism problem is figuring out when two graphs are the same. So do you think this is the same as this?
Well, you can sort of like, if you shorten up this line a little, if you adjust the lengths, it would be the same. But depends on like what you mean. Is like the same, exact same shape. Like, is it similar to that other graph or not?
Yeah, you're right. It definitely depends what we mean. So what we mean in the graph isomorphism problem, or I shouldn't say what we mean, what mathematicians mean, because I actually don't know that much about it, is just are the collection of points and connections the same. So not things that you might be studying in geometry, like the area or the lengths, but just the collection of lines and points. So what do you think? You think these two are the same?
I think they are.
You think they are?
Okay. I would say if they're the same, then you don't have to create any new points or lines to transform this into this.
Okay. And do you think this is the same as this?
I do not, because you also, the first thing is you have like more points and more, one more point and one more line.
So you'd have to create a point and a line.
Okay. All right, very good. And so the first thing we're going to look at, I just want to make sure I get it drawn right. So I'm going to go with a square again. And I'm going to have connections that go like this. But it actually doesn't matter if the connections cross.
Okay.
If you wanted, and we're going to investigate whether that is the same as this. Okay. So first, I want you to tell me just your initial guess, and then in the next video we'll study this more carefully. Is this graph the same as that graph?
I think it is.
Okay. And what do you think?
I think it is.
Okay.
Because you have this again. You've got the same number of lines and the same number of points.
Okay. And what's your reason?
4.6 lines.
Well, I see there's this middle point that has three connections. Or well, they all actually have three connections to them, and they all do on this graph too. So all the points have three lines connecting to them.
Okay. All right. Well, let's go to the second video and see if we can study it a little bit more.